Welcome to our quantum deep dive. Today, we are exploring one of the most mysterious particles in the entire universe, all based on the fantastic work of Jörg O. Schneeppert. We're talking about the antineutron. Okay, so to get started, just think about, well, everything. Everything you can see and touch. The chair you're sitting on, the air in the room, the stars way out in the night sky. It's all made of what we call matter. But, and this is a huge but, our understanding of physics says that for every single one of those particles, there's a kind of hidden twin, an opposite counterpart. It's like an invisible mirror image of everything we know. And that mirror world, that's what we call antimatter. Now, the truly wild part, the thing that's so central to our story today, is what happens when matter and antimatter actually meet. It's not just a collision, it's total annihilation. They both just vanish. And in their place, there's this incredible burst of pure energy. It's the most powerful conversion of mass to energy possible. So to really wrap our heads around this, here's how we're going to break it down. First, we'll properly meet our mirror particle. Then we'll take a peek inside it. From there, we'll connect it to a puzzle the size of the entire universe. We'll even look at its potential future power before we tackle what it all really means for reality itself. All right, let's kick things off and meet our star player, the antineutron. Now, it's the antimatter version of the neutron, obviously, but what makes it so interesting is that, like the neutron, it has no electric charge. It's neutral. And, that neutrality made actually finding it an absolutely incredible scientific detective story. And you can really see that detective story play out on this timeline. I mean, it all started as pure theory, just some beautiful equations from Paul Dirac that predicted antimatter could exist. Then the clues started rolling in. First, they found the positron, the antielectron, then the antiproton, and finally, in 1956, the antineutron. But they didn't see it directly. No, they found it by detecting the explosive energy signature it left behind when it annihilated. That was the smoking gun. So we know it's the neutron's mirror image, but what does that really mean, on a deep quantum level? What's actually going on inside that makes it so perfectly opposite? Well, this is where it gets really, really cool. On the outside, they look like identical twins. They both have zero electric charge. But if you could crack them open and look inside, their guts are completely reversed. A neutron is made of quarks. An antineutron, it's made of antiquarks. And this gives them an opposite baryon number. You can think of it like a fundamental quantum ID tag. Matter gets a +1, antimatter gets a -1. And that one tiny difference is what leads to that final explosive outcome. One just interacts, the other annihilates. Exactly. I mean, that word, annihilates, it's so dramatic. It's not like two cars crashing. It's something else entirely. So let's walk through what that process actually looks like. Okay, so picture this. It's this incredible, violent cascade. First, you have contact. Because it's neutral, an antineutron can get incredibly close to the nucleus of an atom without being pushed away. The second it makes contact, poof, both particles just cease to exist. All of their mass, every last bit, is converted into a flash of pure energy, exactly like E equals mc² predicts. And then, just as quickly, that energy reforms into a shower of brand new particles, usually pions, that fly out at unbelievable speeds. It is the ultimate transformation. And that very process, annihilation, takes us from the tiniest quantum scales right up to a truly cosmic mystery. The antineutron isn't just some particle in a lab. It's a major clue in one of the biggest unsolved cases in all of science. This is the question. Seriously, it's what keeps astrophysicists up at night. Our best theories say the Big Bang should have created a perfect 50-50 split of matter and antimatter. But if it did, they should have all found each other and annihilated, leaving behind a universe filled with nothing but light. But that's clearly not what happened. I mean, we're here. The stars, the galaxies, it's all matter. So what gives? Where did all the antimatter go? Right, so back in 1967, a physicist named Andrei Sakharov came up with a set of conditions. He basically said that for matter to win out, some fundamental rules of physics had to be broken in the chaos of the early universe. The beautiful symmetry had to be shattered somehow. And the big one for our story is that first condition. The baryon number couldn't be constant. There had to be some process that could create more matter than antimatter.
And that leads us to a really mind-bending idea. What if a regular neutron with its baryon number of +1 could just spontaneously flip and become an antineutron with a baryon number of -1? This idea, it's called neutron-antineutron oscillation. It would directly violate that sacred rule. Now, our current laws of physics say this is impossible, but if it happens, even incredibly rarely, it could be the key to solving the whole puzzle.
So has anyone ever seen this happen? Well, no, not yet. Scientists have been running experiments for years, basically just watching huge numbers of neutrons to see if one will flip. And what they've found is that if this oscillation happens at all, the time it takes is at a minimum over 100 million seconds. That's more than 3 years for a single flip to occur. So it's ridiculously rare if it even happens. But the search is on because finding just one would literally rewrite physics as we know it. But just because it's rare doesn't mean we can't dream about it. Because when you talk about the sheer power locked up inside an antineutron, you're moving from fundamental physics into the realm of science fiction. And the numbers here are they're just mind-boggling. I mean, look at this. The energy from TNT is in the millions of joules. Nuclear fission, which powers our nuclear plants, is in the tens of trillions. But antimatter annihilation? It's over 1,000 times more powerful than that. We're talking about a completely different league of energy density. It's staggering. But okay, before I start designing our antimatter-powered spaceships, we need a serious reality check. The challenges here are just immense. First, making this stuff is unbelievably hard and expensive. And then, how do you even store it? It annihilates literally anything it touches. And because it's neutral, you can't even use magnetic or electric fields to hold it in place. It is a monumental, maybe impossible engineering problem from top to bottom.
So for the foreseeable future, the true value of the antineutron isn't as a fuel source, but in what it teaches us about the universe. So let's wrap this up by looking at the deeper, almost philosophical meaning of this strange, ghostly mirror particle. Yeah, this really gets to the heart of it. The antineutron isn't just an opposite particle. It's evidence of a deep, fundamental symmetry baked into the fabric of the universe. It suggests that reality is built on these kinds of dualities. For every action, a reaction. For every particle, an antiparticle. It really makes you wonder, what does it mean for something to exist if its perfect cancellation also exists somewhere out there? Which brings us to this final question to leave you with. If our universe is really just one half of a perfectly mirrored whole, then what are we actually looking at? Are we just the part of the reflection that by some cosmic fluke happened to survive? The antineutron is a constant reminder that beneath the solid reality we see, there's a whole other set of hidden rules, a mirror world that shaped absolutely everything. This deep dive was based on the comprehensive essay by Jörg Owe Schneppet. To explore more, you can visit schneppet.de. Thank you so much for joining us, and goodbye.
Schneppet.de is a private project by Jörg Owe Schneppet dedicated to promoting quantum technology. Its mission is to present knowledge in a way that is clear, precise, and transparent for those just starting out, as well as for experts who wish to deepen their expertise. He firmly believes that education and access to well-structured information are the keys to unlocking the full potential of this future technology. If his work helps you realize your own visions and actively and consciously shape quantum technology, then the goal of his project has been achieved.